Hey there, welcome back, Happy Fabricators. In this video, we're going to be going over the flux core capabilities of the Primeweld Mig 180 here. So this is a pretty common question I've been getting lately, is how this machine runs with gasless flux core wire. So we're going to go over the capabilities of this machine with gasless flux core. We're going to show you how to set it up and some techniques to get you on the way. So once again, thanks for watching AM Custom Fab. Make sure to like, subscribe, turn on those notifications, and let's get going. Okay, so before we get started, I want to give a quick brief explanation on what flux core welding is versus MIG welding and why this might be a valid option for you. Okay, so the difference between gasless flux core and hardwire MIG welding. When you're welding mild steel specifically, mild steel is what you call a reactive metal. So what that means is once it meets its molten temperature or melted temperature, it needs to be shielded from the atmosphere so it doesn't absorb or consume any contamination from the oxygen and air around it when it's at that molten temperature. So what gasless flux core does is it creates a chemical reaction that creates a hard shell or shield or kind of a blanket around that molten puddle to seal it from the atmosphere while you're welding. Whereas hardwire MIG welding, when you're using gas, uses a blanket of inert gas or argon to create that envelope and shield it from the atmosphere. So why would you want to use flux core on your MIG 180? Well, there's a couple valid options. Number one is cost. Like I said, this is a gasless flux core. So by doing this, you do not have to invest the extra money into having a bottle. And in some cases, depending on your location, a bottle of gas could cost upwards as much of the machine itself. So that's going to be a good plus. Another benefit to flux core is its portability. Also, because you are not lugging or packing a gas tank around, you can still make good structural welds with gasless flux core. The primary reason I don't care for it is it's just a little bit messier. So let's get this machine set up with some flux core and see how she performs. Okay, so the first thing when running flux core that we're going to need to change out is our wire, because I've been running a hard wire in this machine. So all we got to do is take our other wire reel out, release the tensioner. I'm going to give this guy a clip. Make sure you hang on to it so it doesn't run away on you. And then I'm going to run this back and fold it through so it doesn't unreel on me here. And then something I like to do when I pull it out of the machine is I like to stick it in an airtight sealed bag, because I live in Oregon, and when I throw this thing in the toolbox, I want to know that it's protected from the moisture. So that's just something to consider. So on this machine, I've been running the 10-pound roll. And what you got to do is get in here and take this inner nut out. So this wire here is E71TGS. Now another thing to consider when you are picking a gasless flux core wire is whether it is multi or single pass. This is a single pass, meaning that you cannot stack passes on top of each other, at least with the flux on it. I feel like if you clean up each pass really well with a wire wheel, I'm sure you can do multiple passes, but correct me in the comments if I'm wrong about that. Make sure it's winding off the bottom side of the reel here. And then screw that back on just so that spring is holding just a little bit of tension so it can't freewheel. The second thing that we're going to change to get this machine set up for gasless flux core is our drive roller. So there's two different types of drive rollers that you need to be aware of. There's the hardwire drive roller that comes factory with this machine. Looks something like this, and as you can see, these grooves in here are smooth and they've got different sizes on it, like this one's for 025 and this one is for 030 or 035 wire. And then there's the flux core rollers. Now if you can see on this guy, the flux core rollers have these serrations on the inside of the grooves. So what those serrations are for is, on the hard wire you do not need the serrations because it's a hard wire. You can clamp down on that wire really tight and it's not going to deform it. With our flux core, we are not going to be able to use as much clamping force on our drive pulley as before, because we have that soft flux layer on the wire itself. If you clamp down on it and crushed it with a standard roller, it's going to deform that wire and make it so it does not feed as smoothly through your MIG stinger and can cause some undesirable results. So the final thing we're going to be doing here to get this thing set up for gasless flux core is changing our polarities. So we're going to want to turn the machine back off because we're going to be taking electrical lugs out, and you definitely want to make sure that your machine is powered down, and probably even better off unplugged when you're doing this. But when you're running gasless flux core, you want your machine set up on DC electrode negative. Now, the cool thing about Primeweld Mig 180 is they have these lugs right here on the front of the machine. So as you can see currently, they have a little torch lead going to this pigtail, and then we have the negative side going to our ground lead, which is clamped down to the table here. All we got to do to switch these around is twist the lug out. We're going to twist our ground clamp out, stick the ground clamp in the positive lead, and stick our torch pigtail in the negative lead. We'll get our PPE on here. I've got some 16 gauge weld metals online coupons here. There's 10% off discount code for those guys in the description if you'd like. And let's see how she works. That looks pretty good. We'll do a little bit of cleanup on this guy. That's the other difference between your flux core and your hardwire MIGs, is you are going to have a little bit of slag to clean up. So you need yourself a slag hammer, a little wire brush. This is actually the little one that this machine comes with. Okay, so we ran a couple sizes with our machine plugged into 110, and then I'm going to run some on 220, and then we'll come back and show you guys the results. Okay, so we actually got some pretty satisfactory results. We ran a couple coupons with 16 gauge, 3/16 and 1/4 inch while the machine was plugged into 110 wall outlet. I just want to encourage you guys, if you are running off that 110 wall outlet, make sure that is a good burly outlet. The factory recommends a 30 amp breaker, and I'd recommend at least that outlet have 12 gauge, but sometimes you gotta do what you gotta do. So, and we'll show you what they look like here. First off, we have our 16 gauge. And these first three were plugged into 110, so fairly clean little welds for plugged in 110. And then we've got our 3/16 off of our 110 wall outlet, and we got a pretty clean, nice little weld. I mean, it's a little undersized for 3/16, but it's really not bad. Now, something to take note of on this side, if we look closely here, we have a little bit of porosity and pocking. Now, something to take note, when I said earlier this gasless flux core is only a single pass application. What happened here is I'm used to running a kind of a semi-whip form when I'm running hardwire, especially on a heavy gauge material when I'm plugged into 110, because you got to kind of like dwell a little longer to let that heat build up. That is something you cannot do with that gasless flux core, because when you whip around and bring that wire back into that existing puddle, it's more or less doing the same thing as if you were making a second pass over it. You're kind of going back into that flux, and that's going to cause you problems. So make sure to consider that. You want to do nice, even, straight passes. If you're doing thicker material, just slow it down. So this is our 1/4 inch piece plugged into 110 there. It's a little bit cold, but it's really not bad for a cold piece of 1/4 inch on a 110 flux core welder. Those toes on that one aren't quite as wet in as I would like to see them, but like I said, we are running off a 110 wall outlet. And then we can move over to our 220. So this is 3/16 with thing plugged into 220, and she wet in nicely and got a nice qualifying width on that weld. Toes are wet in nicely. Same with the other side. I have one little pock right here, porosity, and I'm not sure what that was from. I don't know if maybe I came back and whipped over that accidentally, but that is definitely a habit that I would have to break if I use the gasless flux core. And then finally we have our 1/4" piece. It was on 220, and that's looking pretty good. It's not a very long weld, so it's hard to tell, but it went out pretty nicely. Something I noticed with the flux core is you definitely want to go past the weld. It seems to crater out really easy when you terminate the weld. So with hardwire, you can just stop at the end and it will bead up and have the same profile, but it seems to leave this crater. Okay, so as for my final thoughts on using the Primeweld MIG 180 with gasless flux core, I feel like it performed very well. Definitely better than some welders that I've used in the past with this process. Now, this process definitely has its pros and cons. It's definitely a more affordable way to go because, like I said, you do not have to have that shielding gas. The other pro to this process is, like I said, mobility. You don't have to lug that gas tank around. A lot easier to do some field repairs and stuff of that sort. As far as this process in direct relation to the Primeweld MIG 180, I really like that their leads and lugs are right on the front here. It's easy to access, so if you're jumping back between processes or down the road you want to upgrade, you don't have to get inside. Not that it's a huge deal, but you don't have to get inside and undo nuts and bolts and switch things around. It's right here, easy access to change the polarity on this machine. So hopefully this was useful information to further your choice on whether a Primeweld is the machine for you. Once again, thanks for watching, guys. Make sure to like, subscribe. If you want to see more fabrication content relating to Primeweld, let me know down in the comments, and go build something, guys.